Alright, so let's continue with our problems. So number 3, we're given a few parts, and we are also trying to find the particular form, a particular solution of the form of it for the given g of t's. Okay, so let's do A. Alright, so in this case, now that we know the previous proof, we can utilize this part that we have two parts added, then we can simply find the different particular solutions and then we can add them. So utilizing that, we can go back here and let's find a particular solution for this. Okay, so of course the coefficients get ignored, and if you go back to the homework description, notice we have all the coefficients, and under the g of t we have a's and sometimes b's, but all of them just kind of get ignored. The capital A's and the lowercase a's are different, definitely different values than different values. So all of them get ignored, and it looks like we're going to be using, also notice that cosine of beta t and also sine of beta t have the same format. Okay, so utilizing that, let's go back here, and the guess for this first part A, for cosine of 6t, the particular solution guess would be, so for this part, that will be A cosine of 6t plus B sine of 6t. And what about our guess for the second part? So our guess for the second part, of course, -9 gets ignored. So we're just looking at sine of 6t, and that's going to be, already used A and B. So I'm going to use C of cosine 6t plus D sine of 6t. All right, and what do we do here? And then from the parts, this slide, we know that these two should be added, since those two, the red and the blue parts, are added together for our g of t as well. All right, so if they're added, I can just combine. That would be A plus C cosine of 6t plus B plus D sine of 6t. A plus C is some sort of coefficient, or I can just rewrite that as A cosine of 6t. Likewise, B plus D is some kind of coefficient. It's unknown for us now, so we can just write it as B. Or you can write any other unknown subscripts. And that's it. So this is our particular solution to part A. Alright, let's go ahead and do similarly for part B. So it seems like part B has two parts to it. The first part is this exponential part, and the second part is just the number. Alright, so let's take a guesses for those. The guess of e to the power of 7t, the particular solution for that, is just A, capital A, e to the power of 7t. And the guess for just a number is just another number. Okay, so that's going to be our particular solution. And what do we do with these two parts? We add them. And this is it. It's pretty simple. So we can use this particular solution and plug it into our general equation to solve for A and B. Let's go on to part C. So it looks like this part this could be rewritten as 6t squared plus 9 minus 7 sine of 3t. If I rewrite it like this, I can guess the particular solution for this, which will have the format of a t squared plus t b times t plus c. Okay. And the guess for that part with the sign, this is going to be d cosine of 3t Alright, so that's so that's going to be d cosine of 3t plus e sine of 3t. What do we do with these parts? We add them, okay, and that's going to be, this is just our y particular solution for part C. Alright, let's go ahead and take a look at the last one. Yeah, so it seems like this has 3 parts. This is the first, this is the second, and that's the third. Alright, so let's take down the guesses together, and then we can all add them together. So that will take in the form of a times e to the power of negative 3t. We're done with that part. Alright, so how about this one? That one, first we have the e to the power of negative 3t, and that should be multiplied with b. We already used a, so b cosine of 6t plus c sine of 6t. Okay, and lastly, that part will have a, b, c, so I can continue to use d cosine of 6t plus e sine of 6t. All we do, we all add them together, and this would be the particular solution for t. So as we go, it'll be kind of it will require a lot more of algebra to solve for all of the unknown coefficients. In this case, we have to solve for a, b, c, d, e, all 5 unknowns. But doing this, it is definitely doable, and we will be able to solve for all. And I think we've seen it, we've actually done it in our previous problem. Okay, so take a look at number 4. So we're back to this. If you notice this, this is the left-hand side part that we used a lot. And let's do a quick review. We used the left-hand side to find the complementary solution. All right, so how do we find the complementary solution? We've done a lot of practice doing just that when we were solving for the homogeneous differential equations, which means when we have the right-hand side at 0. So what we did is we used this, r squared minus 4r minus 12 equals to 0. And this allowed us to solve for r, which would be negative 2 and 6. Yeah, okay. So now what we did, that y, the complementary solution of t, this was c1 e to the power of negative 2t plus c2 e to the power of positive 6t. So this was our complementary solution. Let's take a look at the particular solution. The particular solution, this pops up when we have a non-zero solution on the right-hand side, which is this case. So we have to guess for the general form. In this case, the general form would be a times e to the power of 6t. Alright, so that's the second part. Alright, so let's take using this, let's plug it into our original equation. So y double prime of particular solution of t, this is the y of t differentiated twice. So differentiated first would be 6a e to the power of 6t, and do it again, we will have 36a e to the power of 6t. And y just once differentiated, this would be, we said it before, 6a e to the power of 6t. And we can plug these values in, so this would go in here, and the derived one time would go in here. So plugging that in, we have 36a e to the power of 6t minus 4 times 6 is 24. Sorry, 24a e to the power of 6t, and we have negative 12, just the original equation, a e to the power of 6t. And this would equal to on our equation, we're given as e to the power of 6t. Okay, so if we do this, the left-hand side, that nicely equals to 0. So 0 equals 2e to the power of 6t. Normally, solving this equation should give us to solve for a. But in this case, it just kind of completely went away, and we get to this weird thing, 0 equals to e to the power of 6t. And this is never true. We can never get 0 in an exponential form equation, because if you just graph this, it'll going to look like this. So it'll get very close to 0 as the t value decreases, but it'll never, in fact, get to 0. So this is why, although this example looks simple, but we come across our first problem where this is not possible. So just to give you a hand, in these cases, when you guys are not able to solve for A's or B's or C's, then our particular solution is going to be, this was our original one, 6t, as given here, but we just add a constant to it, which is not a constant, sorry, our variable to it, which is t. Okay. So this would be actually our particular solution, and this is the part, just like when you are first learning to solve the algebraic equation, it just needs a lot of practice, because it does follow differential equations alike. It does follow around the particular rules. So we will be doing those more, and probably towards the end of this week, I will post some additional homework problems to it, and I will post all the solutions to it as well towards the end of the week. All right, so but keep that in mind, that there will be some cases where if you follow all of these rules that we've been covering for the past 2 weeks, sometimes if you come across the findings where it just doesn't work, then you would have to add that additional variable to it.